Greetings and welcome. We're talking about CUDA simplifying radicals, SimpRad number 3. And here we go. I've got a cubed root of a negative number. First of all, can I take a cubed root of a negative?
No.
Yes.
Okay.
Even roots of negatives do not exist. Cubed roots or odd roots of negatives do, however. And, in fact, they only have one answer. It will also be negative. So now my question is there a perfect cube that goes into 162 as a factor? So let's see, perfect per cub. What are some perfect cubes? We've got 1, we've got, no, 3, 2 squared is 8, my bad, what am I talking about? I was just going with a wrong list there. 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, etc. Now, I actually only have to kind of check it up to the halfway mark of this, because if it's a factor, maybe it's being multiplied by 2 or something, and there couldn't be one larger than that, unless it was being multiplied by a non-integer, and then it's not really a factor, is it? So this is going to be the same as the cubed root of, and now my question is, let's see, do any of these go into 162? 1 does, but that's not helpful. 8 would go into 160 20 times. Does 27 go into it?
Yeah.
How many times?
6.
6, is it? 6 times 7, 42. 6 times 20, 100. Oh yeah, good catch, friend. So let's see, this is going to be the same as the cubed root of negative 27 times the cubed root of 6. Now, the cubed root of negative 27, K-S, what is it? Anybody?
9.
No?
3.
3, because 3 times 3 is 9, times another 3 is 27. So cubed root is saying what number multiplied by itself 3 times is this? And better than 3, how about negative 3? Times the cubed root of 6, and 6 does not have a cubed root that simplifies. So, voila! Next problem. Here we go. Number 7. Let's think about the perfect fourths. So 1 to the 4th is 1. 2 to the 4th is 16. I think you're right. 3 to the 4th. Let's see. 3 cubed is 27 times another 3 is 81. 4 cubed, or let's see, 4 cubed was 64 times another 4. Is it 256? That sounds rightish. Or sorry, times another. Yeah. Okay. And 120 or 5 to the 4th, I think is 625, something like that. And they keep going forever. Forever. So let's see. Do any of these go into 128? 1 does, but that's not helpful. 16 does? Yeah, well, 128 is a power of 2. 16 is a power of 2, so that sounds good. How many times does 16 go into it, do you know?
4. 5. 6.
I think it's got to be 8, yeah, right?
8.
80 plus 8 times 6. Wait a minute. Wait, 8 times 6, 48, right?
Yeah.
Plus 8, yeah, okay. Whew. Yeah, that old 7 times 6, 8 times 6 thing, man, classic, gets me every time. So let's see, that's going to be, I already forgot, 8, yeah. It had to be another power of 2 since I knew that 128 was a power of 2. How about, let's see, the 4th root of n to the 8th. That's going to be an n squared. Question, does Connell's rule apply? Does this have absolute value show up? Even, absolute value. Okay? So, let's simplify this. 4th root of 16 is 2. Absolute value of n squared. Does Hank's rule apply where I can remove the absolute value? Yes, because it's even. N squared is already positive. Absolute value, you're just telling me something I already knew. You're a little bit redundant here. So that's n squared times the 4th root of 8. If I had a cubed root of 8, I would know what that is, but 4th root, no. And notice I actually kind of left this awkward space in between these because I didn't want this 2 and 4 to become friends. So I'm like, no, you guys stay away from each other. Because otherwise it would look like n to the 24th power or the 24th root of 8. Bless
you
you.
know that they're bad for each other and they don't mix well.
Well, they're both
Well,
positive people.
Maybe it's just like Montague's Capulets. I don't know.
Maybe like one, like, did something bad to their one.
Actually, 2 and 4 are some of the only numbers where 2 plus 2 is 4, 2 times 2 is 4, and 2 squared is 4. What? They are best friends. They are meant for each other.
Except for 2 is always with other numbers as well. It goes into everything.
Every
So,
even number.
Every even number, yeah.
yeah.
Anyways, yeah. Okay, here we go. 6th root. What? Guys, why'd you give me this problem?
Which one is this?
17.
Okay.
Oh, wait, I gave you this problem. I guess that makes sense. So let's see. What are some perfect sixths? I don't even want to say that word. Perfect sixths?
Perfect 6.
That's my least favorite word. Saying this fraction, this is my least favorite number in the universe. 5/6. It's the worst. I didn't realize that it would show up here.
6.
Because like 1/6 is a singular amount of them. 2/6 would reduce, right, to like 1/3, right? 3/6 reduces, 4/6 reduces, 5/6. You have to say the sixths. A plural amount of sixth. Ugh.
Oh,
Not important for that class.
Perfect sixths. Yeah.
I was loving
Is he a fan of sixths?
He said
Six,
666.
yes.
Oh.
He says 666.
But that's a regular old number. That's not sixths. But anyways, perfect sixths. 1 to the 6th power is 1. Okay, good. I'm on a roll. 2 to the 6th. So 2 times 2 is 4.
times 2 is 8.
Wait. Let's see. Did I keep track? Yeah. 2 squared. Yep. 4. 8. 16. 32. 64 is the next perfect sixth. I'm not going to go any further from that. Is 64 the number I hope? Does 64 go into 448? Let me open up my calculator. 448 divided by 64. It goes in 7 times. Yay! So I'll have the 6th root of 64 times the 6th root of 7. Wow. X to the 7th. Oh, why couldn't it be a 6th? Well, I could make it x to the 6th, right? 6th root of x to the 1st. Notice x to the 7th comes from these two guys.
Wait, why did we do that?
Because I'm trying to break x to the 7th into the factors where one of them has the largest divisible by 6 exponent. That was a really wordy response. I don't know if it was the most efficient, but it was accurate, so I'll count it. And then the same with the y's. I'll break y to the 7th into a y to the 6th and a y to the 1st. So, all right, let's simplify this. 6th root of 64 is 2. Okay.
This is confusing this person.
Let's see. Let me simplify all the ones that can be simplified first, and then I'll put all the other ones together. The 6th root of x to the 6th is x. Does absolute value show up? Even, absolute value. The 6th root of y to the 6th is y. Does absolute value show up? Yes, even, absolute value. Let's see, then all of these other guys are hanging out inside of 6th roots. I've got 7, I've got x, and I've got y. Now question, Hank, my friend, does the Hank rule apply? Can I drop those absolute values?
No.
Like a bad date?
No.
No. Which actually, that's funny, drop it like a bad date. thing I thought of then, right there, was Indiana Jones, Raiders of the Lost Ark, in which the monkey eats a bad date and dies and drops it. What? Oh man, you didn't even think I was going there. Wow, that was incredible. And actually, Indiana Jones's friend, I don't remember his name, but he's all like, bad dates, because he grabs Indiana Jones's hand or something.
How do you get 6?
What? He was in another film. He was in the second film, which was darker and was the very first PG-13 movie ever. PG-13 did not exist prior to Indiana Jones and the Temple of Doom. Yeah, there you go, friends. And also, that I don't know if that can take credit for it, but that definitely was, of a trilogy, darker middle, darker second film, is a classic move right there.
Were you too young to take it?
Oh, I was terrified. Every time I was scared, they ripped their hearts out. I'm scared still. I remember my dog was scared of that movie. But anyways, what simplifies into 2mn squared times the cubed root? Okay, what is going on here? Basically, this is saying, oh, you think you're cool? Can you do it backwards now? Oh, what? So let's see. Let's see if we can figure this out. If I wanted to take this n squared and fit it back inside of a cubed root, okay? What did I do to take it out of the cubed root? I would have divided by 3, right, to get that 2? So to go backwards, I must be multiplying by 3, right? Multiplying by 3, does that make sense?
Yes.
Okay, so let's see. So I'm going to have a cubed root. I'm going to have, let's see, well, maybe I shouldn't have started with the n. Well, but I'm raising these exponents to 3's in order to fit them inside. So I'll have 2 to the third, m to the third, and n to the 2 times 3, which is 6, right? Okay, and then I've still got these other guys hanging out because they were all hanging out in here first. They're like, hey, welcome back to the party, friends. Right?
It's never going to be the same.
So let's see, this is going to be the cubed root of, let's see, 2 cubed is 8, times 5 is 40, m cubed times m to the first, oh yeah, come on guys, represent m to the fourth, and n to the sixth times n to the second, add those exponents, what do you know? And let's see, I can even get rid of this extra long vinculum on that radical.
How do you get from
2 to the third was 8, and 8 times 5 was 40. So, yeah. Just trying to save us a little bit of work. So anyways, that was the homework last night, and also a brief summary of the history of Indiana Jones. I hope you appreciate it. Do you think, wouldn't that be amusing if hundreds of years from now, people who are archaeologists studying our culture find the Indiana Jones films? Wouldn't that be like Inception? Archaeologists studying other archaeologists, but these were films of archaeologists to make the field of archaeology look cool?
Are you still recording?
I am. But just think about that. That's crazy. Also, by the way, if you go into archaeology, just, you know, there's going to be a lot of digging and like brushing dirt off of stuff. So it's not as adventurous as Indiana Jones makes it out to be. Don't want to disappoint you. Mathematics, on the other hand, that's a career path you should look into. It is way more exciting than you can imagine. But bye, friends. Bye-bye.
What about